So myself, Zainab Ahmad, and I'm here to present my article presentation to NLCAI conference, which is titled as Information Retrieval versus Cache-Augmented Generation versus Fine-Tuning, a comparative study on Urdu medical question answering system. So let's start with the outline. This presentation includes introduction, literature review, problem statement, corpus generation process, proposed methodology, results and analysis, and finally, I will present the conclusion and future work. So let's start with introduction. Well, the first important question is, what is medical question answering system? So it is the process of AI-based medical question answering, uses language models or the large language models to understand your health questions and search trusted medical texts to find the best answers. So there are different types of QA systems, which is IR, information retrieval. In this, AI finds and copies the exact answers from trusted text or the repository, while in RAG, which is in this AI first retrieves relevant text and then rewrites it into a clear response. While if you talk about the generative QA, in this AI writes a new concise answer by learning knowledge. So here I have an example of QA system in English language. And the question is, how many people are affected by this specific disease? And we have the corresponding answer, and they have mentioned the stats and all the things. So similarly, we have the same QA example for Urdu language. This QA pair is the exact translation of the previous English one. This is just to show how the QA system for Urdu language looks like. To better understand the medical question answering system, we have divided this into input and output. So the input to the system will be a medical question posed in plain natural language, while the output will be an evidence-based answer, which is verified against reputable medical sources, and we will present it in clear everyday language, which is a natural language. Then it comes a question why we are doing this. So here we have the applications in academic research, medical education, and clinical support. The research focus is to develop corpora and methods for Urdu medical question answering system. Okay, so we had a quick introduction. Now let's move to the literature review. Here we have presented the recent literature, which is from 2025, to present how the importance of the problem, like how many people are still working on the problem. And we can see the most commonly used dataset is MedQuAD, and along with the other corporate as well, of course. Different techniques are performed like RAG, IR, fine-tuning, along with the LoRa modules, etc. And we have their corresponding results as well. One important thing here is that there is no corpora for Urdu language, like to the best of our knowledge. No one has worked on that QA system for specifically for Urdu language. Now here comes a question as well, why Urdu language? Because it is the 10th most spoken language of the world, with around 270 million speakers. So yes, it is important to build a good system for such a large pool of people. On the basis of our literature, we have formulated our problem statement, which is to develop an Urdu medical QA corpus using state-of-the-art large language models and apply, evaluate, and compare state-of-the-art information retrieval, Cache-Augmented Generation, which is the most recent technique proposed, and fine-tuning, which is based on technique and fine-tuning based on techniques on proposed corpora for its potential applications in academia, medical chatbots, and related applications. So now let's move to our corpus generation process. Well, we have selected the MedQuAD dataset, which we have seen used them many studies, but that is in English language. So we have translated that using prompt engineering technique. While translation, we make sure to preserve the medical terminologies like BP. So we made sure that while translation, the LLM does not translate it as bay and pay, which is the alphabets of Urdu language, as BP is a very commonly used terminology, so it should remain consistent. One important thing as well is we also make sure to preserve the answer length. So as we are using LLM, so it does not generate a summary of that answer, just simply translate that. And then we have Urdu language corpus, and we named it as Urdu MedQuAD 25. Let's see some key highlights. As a source corpus, we have selected a subset of MedQuAD dataset, which is of 3,152 QA pairs. And for translation, as I mentioned, we have used OpenAI Forum Mini. Well, why OpenAI Forum Mini? Because of its cost effectiveness and quality. After having translation from LLM, we asked a native Urdu speaking medical students to make sure that the data and terminologies are accurate and it's fluent. If we talk about the average length words in QA are 7, while for answer it's 128 words. And here I have presented sample instance from the corpus. So this is how it looks like. Basically, given the translation for the convenience of the readers, but it will be in Urdu as only. So now let's move to proposed methodology. We have applied information retrieval, cache-augmented generation, and fine-tuning large language models. Let's first discuss the information retrieval. In information retrieval, what we do is we took answers which are in Urdu language. We generated their embeddings and then stored them in a vector DB. So we have the knowledge. So now on runtime, what will happen is we will give question that will be the embeddings will be generated for that question, and then the answers which are stored in this vector DB we will calculate the Euclidean distance to find the best relevant answer for that question. And then we will return the top key results like we have used Persian at 1, 3, 5, 7, and 10. So this is how the IR work. Here we have CAG. For CAG, we will first build our knowledge base. So for that, we will prompt with all the answers we have in our dataset, and we will pass it to LLM to generate our knowledge that will be stored as key value pairs. So at inference time, what will happen is we will provide question along with that saved knowledge we have here. We will pass that knowledge and question to the LLM, and LLM will use that knowledge and generate a response. So that generated response will be evaluated using BERTScore. So here we have fine-tuning method. In fine-tuning method, we will provide both question and answer to LLMs, but after converting them into a fine-tuning format. For LLMs, we have used OpenAI and Llama. They will generate the answer for the given question, and that generated answer is evaluated using BERTScore as well. So if I just give a quick review regarding evaluation media, that for information retrieval, here we have used Persian at 1, 3, 5, 7, and 10. And for cache-augmented generation and fine-tuning the large language models, we have used average BERTScore. So now let's move to results and analysis. So here we have two experiments, experiment 1 and 2. In experiment 1, we took a sample of 500 words, while in experiment 2, we took the whole corpus. Well, why 500 words, 500 instances? Because of the context window of CAG, as we have used Llama. So because of that limitation, we used 500 words. And we evaluated these experiments and the techniques in terms of response quality, retrieval performance, and comparing their efficiency. So here I have the results from experiment 1, in which we took the sample set of 500 and we evaluated all these three methodologies, IR, CAG, and FT. So here I have the results from IR model performance. I used basically three models for embeddings by JinaAI and SentenceBird that we have used in this experiment too. Plus, we made a window of word count to see the variation of the system on the varying text length. And then we have the precision from 1 to 10. As we can see, the best results obtained for both word count 1 to 99 for the shorter one, and for 100 to 199 words, it's on JinaAI. So it outperformed the other one. If we see CAG, we use Llama, and the average BERTScore is 50, which is okay. While FT models, we have used OpenAI and Llama. FT is fine tuning. And if you compare these three, the OpenAI model performed well by achieving the BERTScore of 66%. So here we have experiment 2, in which we use our whole corpus of 3,152 QA pairs. In this, we only compared IR with the fine tuning because CAG window, because of that CAG context window limitation, we can't compare it for the whole corpus. So if we see for IR model, again, JinaAI outperformed for all. And here we have also applied the experts, but we can see their results are very, very low. While the fine-tuning models, again, OpenAI outperformed the Llama by achieving 70% BERTScore. So this is the whole thing. If I conclude, then the Urdu medical MedQuAD 25, which is our proposed corpus, shows that the plain search IR is fastest, while CAG avoids searching. Okay, but we need big hardware because we have discussed that context window thing. Okay, and the fine tuning gives the best answers yet slow. If you have seen that, I have mentioned the I had mentioned the inference time as well. So on the basis of that, we have concluded that. While in future, we are planning to expand the dataset, size of our dataset, because we took the sample set of the MedQuAD original English dataset. And plus, we are planning to apply more methods to have more efficient and robust system. So thank you so much.